Hi everyone, welcome. Today we're going to be doing Leetcode problem number 617, merge two binary trees. So we're given two binary trees, root 1 and root 2, and just as a reminder, a binary tree is a tree in which each node can have at most two children. And they're asking us to overlay one tree on top of the other. So that's basically how you merge a tree. And their guidelines are that when a node exists in that spot for both trees, the new node of the new tree is going to be the sum of those two nodes. And then if there's a situation where a node in that spot exists only in one of those trees, then the node in the new tree is just going to be that node that existed. So in the example here, they have these two trees. For the root node, the root exists for both trees, so the new root is going to be the sum of 1 and 2, which is 3. But for example, this node here, this leftmost leaf only exists on this tree, so the new tree will have that node as its leftmost node, so leftmost leaf. So this is basically a tree traversal problem. If you think of it as you're given two nodes and you just want to deal with those two nodes, well, if you're overlapping those two nodes and one doesn't exist, well, you're just going to be returning the other one. So if not root 1, then return root 2. And similarly, if not root 2, then return root 1. Okay? And then the other situation would be that both nodes do exist, so the new node value will be the sum of those two nodes. So in this situation, in this case, we want to store the new tree in one of these trees. So I'm going to be storing it in the root 1 tree. So I'll say root1.val equals root1.val plus root2.val. Okay, so we're just storing it in the root 1 tree. But the new value of that new tree's node is the sum of the root 1 val plus the root 2 val. And then at the end, we would just go ahead and return root 1. So that is how you do it for two nodes, but we're not doing it for just two nodes. We're doing it for the entire tree, for both of the entire trees. So we need to basically keep doing this for the rest of the tree. So the way we do this is by saying root1.left equals something, and then root1.right equals something. Okay, so the new subtree is going to be stored into the root1.left and the root1.right, and then it keeps going down and down. Okay, so root1.left, well, all we need to do is just call the same function for the root1.left and root2.left because we're comparing the two trees still, right? So self.merge trees, and we're calling it on root1.left and root2.left. Okay. And similarly for root1.right, we are calling it for root1.right and root2.right. Okay, so we're basically treating each node as a root of its own subtree, if that makes sense. So this is the left child of this node, for example, but it does have its own subtree, and when we call this function on that subtree, then the value of root 1 of this node's left node is going to be updated. So let's run that and see if it works for these test cases. Okay, it works initially, and then if we submit, it also works for the rest of the test cases. So there you go. That is how you solve Leetcode problem number 617, merge two binary trees with a recursive tree traversal.